matrices, we are multiplying matrices together. So right here, I have the identity matrix. Now, often when you're multiplying matrices, what you'll figure out is there is a special kind of matrix called the identity matrix, where if you multiply any matrix by it, you'll get the same thing out. So if I have a matrix 2, 3, 4, 5, and I have the identity matrix 1, 0, 0, 1, then I know that everything in this matrix over here is going to stay the same. So my answer is still going to be 2, 3, 4, 5. So let's see how I get that. What I want to do is I want to multiply these two matrices together. So first of all, notice that this is a 2 by 2 because it has 2 rows and it has 2 columns. But this matrix, the 2 by 2 identity matrix, it's also a 2 by 2, right? So it also has 2 rows and 2 columns. The inside numbers always have to match up when we multiply, and these do match up. The 2 and the 2 are going to match up. So I can actually multiply these together. And then my answer is going to be the outside numbers. It's going to be the outside numbers. So this 2 on the outside and this 2 on the outside is going to form the dimensions of the product. So the product is going to be a 2 by 2 when I get done. So how am I going to do this? Well, we're going to multiply row by column. So I'm going to circle the first row. I'm going to circle the first row of the first matrix. And then what I'm going to do is I'm going to circle the first column in the second matrix. So I'm going to circle this first column right here. And we're going to multiply this top row by this first column. Okay, so when I do that, I have 2 times 1, 2 times 1, plus my next number is 3 and 0. So I'm going to have 3 times 0. Okay, so 2 times 1 is 2, 3 times 0 is 0, and when I add up these two numbers, I'm going to get 2. So that's how I know what my first number is. My first number is going to be a 2. And now that I'm done with the first column, I move on to the second column. So I don't stay here. I'm going to cross this out so I know not to go back to that. I'm going to circle the next column. So now let's multiply the first row by the second column. For this one, I'm going to have 2 times 0. So I'm going to have 2 times 0 plus 3 times 1. 3 times 1. So now when I simplify this expression, I know that 2 times 0 is going to give me 0, and I know that 3 times 1 is going to give me 3. And then I add up the products to get 0 plus 3, which we all know is 3. So that's how I know what my second number is going to be. So far, this looks like it's going to pan out. The next thing I'm going to do is, since I'm done with this column, is I'm going to cross it out. I'm done with my second column, so I'm going to cross it out. And then, since I'm done with all the columns, they've all been exhausted, I move on to my second row. So now I'm going to circle the second row down here. And I'm basically going to repeat the process. I'm going to take the second row and I'm going to multiply it by the first column right here. So here I get 4 times 1, that's going to give me 4. 4 times 1 plus 5 times 0. 5 times 0. And when I put these together, I'm going to get 4 in the end. So that's how I know my next number is going to be a 4 right here. So now I'm done with this first column, and then the last thing to do is to multiply it by the last column. 4 times 0, that's going to give me 0, plus 5 times 1 is going to give me 5 times 1, that's 5. And 0 plus 5 is going to give me 5. So there goes my last number. So as you can tell, the identity matrix is pretty weird. It's always going to have a 1, 0 for the first row, and it's always going to have a 0, 1 for the bottom row. And what you'll notice about the identity matrix, and I'll rewrite it up here, 1, 0, 0, 1, is that this is a 2 by 2 identity matrix. And as such, it has 1s going down the diagonal. So if you circle the diagonal right here, you'll see all 1s. And then if you're anywhere off the diagonal, like over here, you're always going to have a 0. So you're going to have ones on the diagonal, ones on the diagonal, but zeros everywhere else. And that's the identity matrix. Now let's look at a different kind of identity matrix. So we know that the 2 by 2 identity is going to be 1, 0, 0, 1. This is the 2 by 2. So if this is the 2 by 2, what would the 3 by 3 look like? The 3 by 3. Well, obviously this one would be different, right? It's going to have 3 rows and 3 columns, so it's going to be a bigger matrix. It's going to have 1 more row and 1 more column than the last one. But you're still going to have ones down the diagonal. So you're still going to have ones down the diagonal, but everywhere else is pretty much just going to be zeros. So you're going to have zeros here, a 0 here, a 0 here, and you're going to have 2 zeros over here. So that's the 3 by 3 identity matrix. And you can keep on going up and up. You know, you can get to the 4 by 4, you can get a 5 by 5, and a 6 by 6, and you can keep going up like that. So the smallest identity matrix is the 2 by 2. That's the smallest one that we normally use. But we can also have a 1 by 1 identity matrix. The 1 by 1 would just have 1 row and 1 column, so it would just be the number 1 inside of brackets. So I hope that's helpful. That's the identity matrix. It's always represented by a capital I. So if I have a 2 by 2, it would be I2. If I had a 3 by 3, it would be I3, and then so on and so forth. And the property about the identity matrix is, before you go, if you have any matrix A and you multiply it by its complementary identity matrix, then you're always going to get the same matrix back. You're going to get A back. And this also works in the other way. You know, if you had I first, but let's say you had A second, well, A times I is always going to give you A back. And that's what the identity matrix does. So, hope that helps.